Dear students, welcome to the lecture series on the topic engineering graphics. Today we are going to discuss about different types of lines used in the engineering drawing. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So we need to understand to begin with what is the significance of different types of lines in the engineering drawing. So lines, they are basically the alphabet of the graphic language, and there are large number of lines which are being used on engineering drawings, and each line in a drawing, it is used in a specific sense. So there are different categories of lines which are being used in the engineering drawing. So they can be categorized in different ways. The first categorization is depending upon the thickness of the line. So we can see that in the drawing which is just in front of us, there are different types of lines which have been used to complete this drawing. So over here we have got the thick lines. So these are the thick lines which we are going to call as outlines. So they are going to represent the outline or the visible edges of any given object of which the drawing is to be prepared. Then the second type of lines, they are medium lines. So the medium lines, basically these are the dotted lines which represent the hidden surfaces, hidden parts of the components. So they are drawn in the medium thickness. Then the third types of line, so they are the thin lines which are basically the construction lines. They can be the dimension lines, they can be the extension lines. So all these lines we are going to draw in thin thickness over there. So this is the first category of the lines that we are going to use in any given engineering drawing. Then the second categorization is, that is, there are certain lines which are continuous in nature. You can see object lines, they are continuous, construction lines, they are also continuous. Whereas there are certain dotted lines, the hidden lines, they are drawn dotted in nature. Then there are chain lines. So chain lines, basically they represent the center of symmetry. So they are basically representing your axis or the center line. So they will be drawn big, small, big, small, big, small. So they are called chain lines. So they are basically going to represent the center of symmetry. They will be applicable for any type of circle. You can see here we have multiple circles, and everywhere we have drawn the chain lines to represent the center of a circle. Then the third categorization is that we are going to use the dimension lines, extension lines, or the leader line. So here you can see a dimension line is the one. On the either side of it you have two arrows, and in the intermediate there is a cut where we are going to write down the size of the dimension. Whereas the extension lines, they are going to define the extent of any given dimension. So they are going to define the start and the end point of any given dimension line. So they are also drawn lighter one or a thinner one. So the dimension lines, they are also drawn thinner. Extension lines, they are also drawn thinner. Whereas the third type of lines, they are the leader line. So many times we don't have space onto the drawing so that we can mention the dimension within the drawing, or in other cases where some specific requirements regarding the manufacturing are to be added, so there we use the leader line. So leader line means you have a horizontal line and then an arrow will be pointing towards the place where the dimension or any note is to be given. So here you can see we have this circle over here, we have this hole, and we have mentioned that it is 0.15 through. It means that we have a hole of this size and it will be a through hole. It can be a partial hole or it can be a through hole. So this way we can put down the instructions either regarding the size of the components or the parts, or we can put down certain machining instructions over there. We can add instructions regarding the surface finish or the tolerances through these leader lines. So all these three lines, they are all basically drawn thin in nature. That is, they will be drawn using 2H pencil. So this way number of categorizations are there. So we need to understand how and where each and every type of the line will be used in the engineering drawing. So we need to understand the basics of different types of lines. And as I told you that whenever you have to draw the thicker lines or the medium lines, the HP grade pencil will be used, and whenever we have to draw the thin lines or the construction lines, 2H grade pencil will be used. So as we have said that there are large number of lines which are used onto engineering drawing. So you can see the list. So there are 10 types of lines that we are going to discuss about. So we are going to pick them up one by one. So let us start with the first type of line, which is called object line or outline, or it is also called the visible line. So this is a line in which we are drawing a continuous thick line. It is used to draw the outline of the visible edges or contours of the object. So here this type of line defines the feature you can see in a particular view. So this will be drawn thick. So obviously if this line has to be drawn thick, we are going to use HB pencil to draw this particular type of the line. So this will be a thick and continuous line. So let us see, you have an example over here. We have this object. So if we look at this object from the front side, so we'll be able to see this particular surface over here in the front view. So since these are all the visible edges or the outlines of the object, so we will need to draw all these lines in a thicker way using the HB pencil. So the HB pencil will be used to draw this particular outline. If we look at this object from the top, so obviously this surface will be available, then the second surface will be visible, then the third surface will be visible, this will be the fourth surface which will be visible, and this will be fifth surface will be visible. So you can see surface 1 corresponding to this. So we have one rectangle corresponding to this, again drawn dark. Then there is second surface corresponding to this web. So this is the first web. This is the crest portion over here. So this is the crest portion rectangle. This one is the second web. So we have drawn the second web again dark, and this rectangle is the bottom surface over here. So this is again the rectangle. Similarly, if we look at this from the left hand side, so similar web will be available on the other side. So this is going to be represented over here. Again, this will be drawn using HB pencil, and then this web surface will be available from the other side also. So this is going to give us the second rectangle which we are able to see. So here we can see that corresponding to this particular object, so whatever object, whatever the outlines they are visible, we have to draw them dark. And these are the construction lines which basically define the overall size of the object without any machining over there. Then the second, you see the examples over here. These are basically going to represent your outlines or the visible edges as we have discussed. So you can see this is a cube. So into this cube we can see 1 edge, 2, 3, 4, 5, 6, 7, and then 1, 2 over here. So all these edges we are going to draw them dark. So this is going to give us the representation of all the visible edges of this particular cube. Similarly, you see this is again another example in which we have got a hexagonal prism. So whatever faces of the prism we are able to see, we are going to draw them in dark continuous thick lines, and these will be the visible edges, top surface we are able to see. But whatever portion of the prism will fall behind these surfaces, so this will be drawn dotted. This is called hidden line. So hidden line will be drawn dotted. This we are going to come next. Similarly, you have this this is again the another object. So over here, once we look at it from the front side, you can see 1, 2, this 3, then 4, and then this 5. So this portion we are able to see. So these visible edges will be there, or the outlines will be visible, and correspondingly you can see we have drawn this portion as dark, but this cut is not visible over there. So this is behind this surface. So since this surface this crest we are not able to see, so obviously this surface line will become dotted. Why? Because we are looking from this side. So this surface is going to hide, it is going to shield this particular crest or the depth over here which we are not able to see. So that is why there is a dotted line over here. Similarly, there is a hole over here. So this hole you cannot see through this side. So obviously there will be two dotted lines corresponding to this particular hole over here. So next type of line which we are going to talk about is the hidden line. In the previous example also we had seen that those surfaces which are visible will be drawn dark and thick and continuous line, that is the object line, but those surfaces which are not visible, which are being overshadowed by the flat surfaces in front of them, those surfaces will be drawn by drawing a dotted line. So this is a dotted line which is uniformly spaced, and this was drawn thick, that is the object line was drawn thick, whereas the hidden line will be drawn in the medium thickness. But again, this will be drawn using HB pencil. So here again few examples we are going to show over here. So the hidden lines, basically they are of medium thickness, they are narrow, short and dashed lines, and the hidden lines, they show the outline of a feature that cannot be seen in a particular view. So those features of the component which you are not able to see in a particular view, they are overshadowed by the other faces of the object. So those will be drawn as dotted and dashed lines. So in order, these dotted lines, they help to clarify a feature, but they can be omitted in certain cases where they clutter a drawing. So here you see this example is over here. We have drawn a cube. So once you draw a cube, you see these faces of the cube, they are visible, but these faces, that is, they are falling behind these two faces. So this face and this face we are not able to see. So these faces will be drawn dotted over here. But if we don't want to show them, we can put the hidden lines off. We'll be able to get this cleaner picture. But usually we have to draw all the dotted lines whenever we are going to go for construction of any given engineering drawing. Similarly, you have another example. You can see this is again a cube block into which there is this space is there, this hole is there for the bolt head, and then the bottom hole is there for the bolt shank. So if I have to draw the diagram of this is my front view. So this is the size of the cube or the outline. So this is the outline of the cube which I am going to draw dark. So you can see this is my outline or visible line which I have drawn dark, but this portion of the bolt head I am not able to see while I am looking from this side. So obviously, depending upon the size of the bolt, I will mark the size of the bolt but draw it dotted. Why dotted? Because I am not able to see this particular feature of the product from this side. So that is why, since there is a hole but it is not visible from this side, I'll draw this as dotted one. Similarly, at the bottom you have another hole for holding the shank of the bolt, for holding the bolt length. So this portion will be drawn once again dotted because I cannot see through that particular portion. Similarly, you have another hole for putting up a screw for securing this bolt into this position. So from here another screw will be located, it will be tightened. So again, since this is a through hole, so I will be showing this as a dotted line. So these are the examples of hidden lines or the dotted lines, and mind you, we have to draw all these hidden lines using the medium thickness, that is again using the HB pencil. Again, these are few examples where the dotted lines are being shown to represent those faces which are not visible from these end. So this is again a block, stepped block. This one is again hexagonal prism which we have already seen, and this is again the same example which I had shown. Earlier we were talking about the visible edge, that is the outline. Now we are talking about this surface. So this surface is being overshadowed by this continuous surface. So this surface is not visible, but there is a discontinuity of the surface. So that is why we need to draw the dotted line. Similarly, there is a hole. We are not able to see this hole from this side, but there is a discontinuity in the surface. So obviously a dotted line or a hidden line will show that there is a discontinuity in the surface within this particular block. Then the third type of the line is the center line or a locus line. Now this line is basically drawn, as I told you earlier, to represent center of symmetry of symmetrical object. These can be square objects, these can be round objects. For all types of round objects or square objects, the center of symmetry will be there. Here again it is a chain line, but it is different from the hidden line. Here you had the uniformly spaced dashed lines, but here you have long, small, long, small and long line. So this way there are alternate long and small dashes over there. So here you can see this is the example of a center line. So center line is drawn as a thin line which is consisting of alternating long and short dashes. So there are small dashes and alternate long dashes are there. So the center lines, they are used to represent the center of a round or cylindrical or a square feature or symmetry to a feature over there. So here you can see, here we have got one block where two holes are there. So for every hole, because you can draw a circle only when the center of the circle can be located. So here the center of the circle, horizontal as well as the vertical center lines will be drawn to identify the center of the circle. So these lines, that is center lines, they provide you the essence of the symmetry of a particular object. So in any given cylindrical object, you can see over here as well, this is again a circular hole and this is an arc. So whenever you have a cylindrical hole, so again there is a center of symmetry. It is a chain line which is a thin line, small, long chains will be there. As I told you, this is a square block. Again, square block is again a symmetrical one. Even a rectangular block is symmetrical one. So here you need to take the midpoint of this side, x dimension, and midpoint of the y dimension. Once you take the midpoint, then draw the chain lines over here, that is the center lines, small, big, wherever these two horizontal and vertical center lines they intersect, this gives you the center point of the symmetry. Similarly, for any type of a prism or any type of a pyramid, the center of symmetry lines they need to be drawn so that you can identify where the axis line is going to lie in case of any given pyramid or any given prism. So this is the example of your center line. Now the fourth type of line is, so here you have three types of lines basically: construction line, projection lines and the section lines. So three types of line. Why we have clubbed them together? Because all of these lines, they are the thin lines and they are the continuous line. So these are thin and continuous lines, and since they are thin lines, they will be drawn using the 2H pencil. So let us see the applications of these three types of the line, that is construction, projection and section line. So here you can see the application first of all of the construction line. So the thin construction lines, they are used to establish the correlation between the different views. So let us say we have drawn three views over here: front view of the object, top view of the object and side view of the object. And you see we have joined these because the object lines are like over here. In the front view, these are my object lines. In the top view, these are my object lines. In the left side view, these are my object lines over here. But if I do not join them by your thin lines and continuous lines, I will not be able to establish the relationship between a front view and a side view. Why? Because if I have these views as independent, I have taken another example. Let us say this is the same object, multiple views I have drawn over here. Now, if you open all of these boxes, you will not be able to get perfect relationship between different views over there because we have not joined them using the construction line. And this gives you the actual idea that they may belong to different objects. All these views, they may belong to different objects because there is no, you see, parallelism between one view or the other view. But over here you can see, if I have drawn this line and this line, it means that the height remains the same in the front view as well as in the side view. Similarly, if I have drawn this line and this line, it means that the width of the object is same in front view as well as in the top view. Here goes the depth. If I have drawn this line and this line, it means that this depth of the object remains same in the side view. So depth in the top view should be same as the depth in the side view. So this way, this gives us an idea of correlation between one view and the another view. Whereas drawing independent views does not give us a confidence that all these views, they belong to the same object. Then other applications of the construction line is basically that construction lines, they are not part of the engineering drawing, but they are drawn to facilitate the construction of many other things of in a given component. So here you can see, if I talk about engineering drawing of this component, this is my front view, this is my top view, this is my side view. But these lines, they are not part of the otherwise object, they are not part of the object, but they are drawn to facilitate or develop a proper understanding that this view is related to this view is related to this, and this view is related to this. So these establish the relationship. Similarly, if I give you another example, let us say there is a pole, and I tell you that this pole or a stick or a rod or a line, it is inclined at 30 degree to the ground. So unless you draw this ground, again this is a construction line, it is not part of the drawing. I am talking about a line which is inclined at 30 degree to the ground. I am talking about a pole or a wire which is inclined at 30 degree. So my point of attention is this wire or a pole or a line, but my point of attention is not this ground. But unless I draw this ground, I cannot draw this particular angle of 30 degree. So I can draw this drawing only when I have this construction line with me. So this will be thin, this will be light, this will be using 2H, whereas my object line will be drawn by using HB pencil. Similarly, again the same example you can see, this is the height of the object which you can see in the front view. So same height you will be able to see from the side view. So same height in front view, same height in side view. But the moment you draw this line, it gives you the confidence that this is the height in front view, this is the height in the side view. Similarly, this is the width which you can see in the front view, this is my width. Similarly, this is the width which you can see in the top view as well. But once I draw these two lines, it means that this width is equal to this width. So I get the confidence that I am talking about the same surface. Similarly, this is the depth. So depth is 50. So this is the depth of 50. So this depth is shown in the top view, and the moment I draw these two lines, you see, once I draw these two lines, so this depth is, I can see even in the side view. So I can see this depth in the top view, I will definitely see this depth in the side view. So the moment I draw these lines, it gives me a confidence that this depth is equal to this depth. So this is how the correlation between the different views can be established. So construction lines, they are not part of the drawing actual, but then they help you to develop proper understanding of the drawing. Similarly, you can see another thing. There is another drawing. I have drawn a cone over here. So this is my object line, dotted line is my medium line, but I have drawn this, I cannot draw this ellipse over here unless I draw all these construction lines. So these are construction lines which are not part of the drawing, but these construction lines A, B, C, D, and this line, this line, this line, this line, and after that I will draw the curves over here. So I cannot draw this particular ellipse unless I have drawn these construction lines over here. So this is the application of the construction lines. That is, they will facilitate the development of any given drawing in many a situation. Then the second type of lines, they are projection lines. As the name indicates, projection. So projection is nothing but it is the image of an object which is formed by rays of sight from the object. You see, these are the rays of sight which are coming from the object or a source of light. So they are falling onto the object and then they are projected onto the plane of projection. So from the object to the picture plane as it appears to an observer stationed at a point. So observer is stationed at this point as an rays of sight. As an observer, we are putting down our rays of sight onto the object and the final picture will be framed over here. So these lines of sight or rays of sight, they are called the projection lines or the projector. They help you to develop the projection or image or view of any given object. So these lines of sight of the observer, they create the view of the object onto the screen. Now you see, there are two methods of these projections. One method is perspective projection. This is what we see as a human being. As a human being, you see, we have this light of source as our eyes over there. But the limitation of the human beings is that all the rays of sight or the projection lines, they are converging at one point. And the limitation of this convergence is, if this object is closest to our eyes, this will appear to be very big. If this object is far away from the observer, this object will appear to be very, very small. But we do not want to draw such a drawing in which if we are looking from close, it will give us a bigger view, and if we are looking from farther away, it will give us a smaller view. So this type of projections, they are not to be drawn in engineering drawing. Whereas in engineering drawing, we need to draw the actual shape of the object irrespective of the distance that we are going to view it. So now we assume in the case of orthographic projections or the parallel projections, that this observer which was located over here, we want to eliminate this convergence, because the limitation of the convergence we have understood. If the object is closer to the observer, obviously it will appear to be very big. If the object is farther away from the observer, it will appear to be smaller. You cannot draw a drawing either close or very far away. We want to draw the drawing of an object irrespective of the distance from the observer. It should give us the same drawing. Here, depending upon the distance, closeness to the observer, it will be smaller or the bigger size. So here what we have done is, we are going to assume that this convergence effect should be eliminated. And how this will be eliminated? We assume that this observer is located at infinite distance. If this observer is located at infinite distance from this object, so this convergence effect will be eliminated. And then what will happen? Whatever these inclined rays or projections were there, they will become parallel to each other. So all the parallel rays of sight, they will be falling upon this object, and depending upon these surfaces, this projection of this surface will be available onto my picture plane or the plane of projection. So this can be horizontal view for the front, for the top view, and the vertical plane for my front view. So over here in the parallel projection, we assume that our observer is located at infinite distance from the object, and the effect of convergence is done away with or eliminated. So all the projection lines or the lines of sight or rays of sight which are there, they will become parallel to each other, and they will be perpendicular to the plane of projection. And this way, if you move this object farther away or closer to the observer, it is not going to make any difference. So same drawing depending upon the actual size of the object will be obtained onto this plane of projection. So here I'll show you the example. Here you can see observer is located over here. This observer is at infinite distance from this object, so no convergence will be there. The rays of sight, you can see they are all parallel to each other. So depending upon this surface, you can see this L-shaped surface we are able to see from the front view. So front view will be obtained on the vertical plane, the top view will be obtained on the horizontal plane, and the side view will be obtained on the profile plane. So we are looking from the front, you can see this L shape is there. So this same, all the projection lines, they are falling onto the picture plane, falling from the observer onto the object onto the plane. So we get the formation of this particular drawing of the object. Similarly, you look at it from the top, this square will be visible and this rectangle will be visible. So this is a square and this is rectangle, and once we draw these lines, they are again the construction line. So my object lines are these ones, and these ones, they are my construction lines. So this is how the projection lines will be used in engineering drawing. Then the third type of the line is section line. So section lines, they are not drawn straight, they are drawn at an angle of 45 degree. So they are again thin lines, but the special characteristic of these types of section lines is that they are used to represent any particular object which has been cut by a cutting plane. You see, let us say we have this object. If we have this object, I want to look into the interior. If I draw the drawing of this object, two dotted lines will be available, which will show that there is some discontinuity or hole within this surface. I want to verify that whether or not there is some hole. What I will be doing? I'll draw a chain line and then put down the arrows over there. I'm going to cut this in two halves. So 50%, 50% over here. And once I cut it, you see, once I cut this object, this is the shape I'm going to get. The moment I cut this object, I'll be able to verify that there was a hole inside this. Similarly, there is a hole over here and I wanted to verify that I have cut this open vertically, and any surface which has been cut will be shown with the help of a hatching line or section lines, which will be at an angle of 45 degree to the base over here. So this is my base. So my section lines will be 45 degree inclined and they will be equidistant line. These are all you don't need to measure, but approximately they should be equispaced line, and these will be thin lines over there. So the sectioning indicates that the material has been cut through to get better view or better insight of interior details of the object. So here we have discussed three types of lines which were thin in nature. Then the next type of line is, again there is a categorization of three lines: dimension line, extension line and leader line. Again they are drawn thin in nature using 2H pencil. So let us see the applications of these three lines. So first line is extension line. So the extension lines are basically thin lines which are used to establish the extent of a dimension. Extent of a dimension, you can see, this is my object. I want to work out the size of this particular length of the object. I want to work out the final overall length of this particular object. So what I'll be doing, I'll be drawing one extension line over here, one extension line over here, and third extension line over here. And the criteria to draw these light extension lines is, I have to separate the extension line from the object line by around 1.5 millimeter. So 1 to 2 millimeter gap should be maintained. You can see wherever I put down the extension line, 1.5 to 2 millimeter gap will be there from the object line. And then my extension line should continue till the point where the dimension line, it should exceed by 3 millimeter. That is, wherever the last dimension line is there, my extension line should override the last dimension line by 3 millimeter. So you see, begin 1.5 millimeter from the object and extend to 3 millimeter beyond the last dimension line. So this is my dimension line. So dimension line is different from the extension line in a way that in dimension line there will be two arrows on the either side. So there will be two arrows, and in the intermediate portion I am going to write down the actual size of the object. Again, this is a thin line, and the restrictions of the dimension line will be provided to you by the extension line. So extension lines, they can cross each other, but they should not cross the dimension line. So there should not be any crossing of the dimension line. And one thing must be understood, that the shorter dimensions should be placed closer to the object and the longer dimensions should be placed farthest away from the surface. So this will prevent the intersection of the extension as well as the dimension line. So here again you can see this for the angular line. You extend this wherever it meets. So here I can put down the angles over there. So this is the application of the extension line. Now the second one is the dimension line. As I told you earlier, this is the extent of the dimension. So again, dimension lines, they are the thin lines which are capped on the ends with arrowheads on either side. You can see there are two arrows on either side, and they are broken along their length to provide a space for putting down the dimension numeral. So whether this is 30 mm, 40 mm or 50 mm. So if it is horizontal, you have to put it like this. If you have to mark the vertical dimension, you have to put it like this. So these are the extension lines. You can see the extension lines, they have crossed, but the extension line and dimension lines, they have never crossed. So do not allow the crossing of the extension line as well as the dimension line. So wherever the space is less, there are two methods of dimensioning. So please check, if enough space is available, I'll put down the dimension numeral within these two arrows. But if the space is lesser, what I can do, I can put the numeral value inside, and arrows I can even put from the outer sides over there. So this way I can add the dimensions onto the engineering drawing. So the distinction between extension line and dimension line must be clear. So extension line will define the limits of a dimension line, and the dimension line will have the arrows on either side with an intermediate break to show the numeral value of the dimension. So again, this is another representation, and one thing must be taken care of: whatever arrows we are going to draw on either side of a dimension line, it should follow the same convention, that is, length of the arrow should be 3 times the width of the arrow. So this ratio of the arrow must be maintained. Then the third type of the line is, which we are going to use over here, they are called leader line. So leader line is basically a thin line. So thin solid line means it is a continuous line. It is a thin continuous line which is used to indicate a feature with which a dimension or a note or a symbol is associated. So here you can see we have got two holes over here. So two holes are to be drawn. So one method would have been, I should have written 25 over here, that is 525 means diameter. So diameter of this hole is 20. So I could have labeled this as 520 and 520 over here. But the conventional of the dimensioning is that the repeatability should not be there. Same dimension should not be mentioned multiple number of times. If the size of both of these holes is same, so you see I have not marked them twice. What I have done is I have marked this diameter over here and using this leader line, and the leader line will be, I'll just show you, there is a horizontal line and there is an arrow over here. So this is horizontal line and then there is an arrow. So check, there is a horizontal line, there is an arrow, and once you draw this, on the top of this horizontal line you put down your notes. So my note is that two holes are to be drawn, they are to be cut, and the diameter of each hole is 20 mm. And another instruction I have given over here, that these holes should be through and through. Through and through means through the entire depth of the component. You can see in the other view the holes, they are running through the entire depth of the object. Similarly, let us say I want to provide special instruction regarding surface finish of this hole. So I could have put down an instruction over here that my surface finish of the hole should be this much. And similarly, if I wanted to have special hardness requirement on this whole surface, again the hardness requirements I could have put down onto this leader line. So leader line is basically to provide with the notes onto the engineering drawing, and these notes may relate to the sizes, they may relate to the surface finish requirements, they may relate to the tolerance requirements, they may relate to the special characteristics like knurling, some reaming is required. So all those special requirements I can put down on the leader line. But all these three lines, they have to be drawn thin in nature. Then the next line is short break line. You can see short break line is basically a zigzag line which is drawn freehand. And this is required for those objects which are having reasonably long line. I'll give you a small example of a tube light. Nowadays we have a tube light which is 4 feet long and the diameter of the tube light is only 20 mm over there. So half an inch or maybe less than that it is there. If I have to draw that particular diagram onto my drawing sheet, if I reduce it by 200 times, so that 20 millimeter divided by 200 times reduction, it will give me half a millimeter thickness over there. So I will not be able to draw the actual dimension details onto my drawing sheet. So what we are going to do, because it is a symmetrical object, any pipeline could be there, any tube light could be there, or any other structure could be there. So I will draw it to a scale of not 1:200. I will draw it to a scale of 1:10 only. But if I draw it to 1:10, obviously my length cannot be accommodated into the drawing sheet. So what I will be doing, because there is monotony in the design, there is continuity in the drawing, I will put down this break over there. So I am not going to draw this to the scale, but this dimension I will be drawing to 1:10 or 1:2 or 1:5. So this reduction in scale I will do only in this side, whereas this length I can manipulate as per my requirement, and this break line will indicate that whatever length I am showing it over here, this is not reduced to 1:2. So basically These short break lines or the irregular boundary lines, they are the continuous thin lines which are drawn freehand, and they are used to show break of an object which extends over a short length of drawing. So there is reasonable reduction. So not very high reduction is there, but reasonable amount of reduction is there. So again you can see this is one method, this is another method. We can show the short break line, because if I reduce any tube light construction to 1:100 or 1:200, the thickness will become very very small. So the thickness of the tube I cannot show it over here. But if I draw it with the help of a short break line, I will be able to reduce this to only 1/2. But this length I can reduce disproportionately depending upon my space availability, and I will be able to draw the sketch because of the monotony of this particular or the continuity of the longer length over there. But if this length is too long, let us say I don't talk about the tube light, which is 1200 mm multiply by 15 mm or 20 mm. Let us say I talk about a 4-inch drain pipe. We talk about civil engineering construction. So we have a drain pipe on a 10-story building. So 10-story building means 120 feet of length of pipe is there, and the diameter of the pipe is only 4 inches. If I reduce it by 1:500, so once again the same problem will be there. So the pipeline is very long, but its length is very very long as compared to the diameter of the pipe. So if this discontinuity is on the higher side, I cannot use the short break line, rather I have to use the long break line. So the only difference between long break line and the short break line is here the freehand zigzag structure is to be drawn, whereas in the case of long break line there is a chain structure like this which is to be drawn. So here you can see this is the long break line. So this is used to shorten very long objects which are having similar shape. I'll give you another example. Let us talk about a railway track which goes from Jammu Tawi to Bombay, and then the electrical lines which are there, or even the railway track, the electrical lines, they might be running in 2 inches length, and the length of the electrical wire may be 2000 kilometer, but the diameter is only 2 inches. So if you reduce it, the diameter won't appear anywhere, but otherwise it is a wire only. So I can reduce the length of the wire dramatically over there. Similarly, a railway track is there. So the size of the railway track, that is the cross-sectional size, it will not exceed 6 inches, 5 to 6 inches only. But the length of the railway track can go into hundreds of kilometers. So if the same thing is to be drawn, because of the monotony, I need to break this on a longer scale. So this is called long break line. So these are again continuously thin ruled lines having zigzags at the suitable interval. So this kinks will be there. So this we call as long break line. So this is for those constructions which are monotonous, similar design, but the disproportionate length versus the cross-sectional dimensions, they are very very disproportionate. Then the next type of the line is cutting plane line. So cutting plane line is similar to your center line, but the difference is in the cutting plane you have got a thicker line on the edges, whereas the intermediate portion is thinner one, and then it is supplemented by arrows on either side. So these arrows can be upwards, these arrows can be downward, depending upon which side you are going to look upon the portion which has been cut out. So the cutting plane lines, basically these are the thick broken lines that extend past the edge of the object. You can see if this is the object, my cutting plane has to go beyond the edges of the object so that I can have complete cutting. In certain cases I can have even the partial cutting, but whatever portion has to be cut, this length of this cutting plane should exceed the portion of the object which has to be cut over here, and it is terminated with short 90-degree arrowhead. You can see at the end there are 2 arrowheads over there. Same here, you can check. If I have to cut this object, so my cutting plane line, which is again a chain line, small big, but the ends will be heavy, and this is supplemented by the arrows. This arrow means that I am going to look at this cut portion in this direction. So if I look at this object, this was the solid object, I have cut it, and after cutting you can see this is what I am able to see. And as I have already told you, the section lines, this portion has been cut, so my section lines will be 45 degree to my baseline or my center line or my XY line. So these are equispaced line section lines which have to be drawn. But over here the idea is about getting knowledge about my cutting plane. So basically, why do we need to draw the cutting planes? Because we want to look into the interior details of the objects. So whenever you have the solid objects, we are going to cut open those solid objects so that we can develop a better understanding of what are the interior details of the object. So for that purpose, we are drawing the cutting planes in many given engineering drawings. Then the next type of drawing is, you can check, ditto line. So what is it? Ditto? Ditto means similar one. So here they are again chain lines, but then these chains, they are in tandem. That is, couple of small dashes are there. So they are again drawn in medium thickness. So ditto lines consist of two dashes which are drawn repeatedly. So here you can see there are two dashes which are drawn repeatedly, and the intermediate distance is relatively higher, and they are used to indicate repeated part of the object drawn. You see, there will be many instances where in any given machinery there are moving components. When the machine is in the idle situations or standstill, this is the component in the idle situation. But when the machine will be working, then this component or a handle may be moving to the other location. So why do we need to show this? Because I cannot plan any other component, I cannot plan any other activity into this area. By putting down this ditto line, I want to show that the idle situation of this handle is over here, but the moment this machine is working, this handle will be moving into this area. If the handle moves into this area, I cannot plan any other activity, I cannot put down any other component over here. Otherwise, if I put down any other component over here, this will lead to hindrance of the movement of this component into this position over here. So ditto lines are used to indicate that what can be the positions into which my components or my parts of the machinery they can move into. So these are also called phantom lines. So the phantom lines, they are used most frequently to indicate the alternate position of a moving object as shown in left hand side view. So this is the idle situation, this is the working situation. So this is just to facilitate that this space I have to keep free of any given obstruction so that there is no hindrance to the movement of this particular handle. Then the last type of line is transmission, telephone and chain lines. Because here you can see again, see there is a small chain and followed by the bigger one. So here you have a chain line which is drawn dark, and the indication of the, it is an indication of the line or the surfaces to which a special requirement apply. Let us say you have this knob over here, this is a knob, and in any given knob at this bolt head we are going to provide the knurling operation. So knurling means to improve the grip. So this is a special operation. So I want to show that this is my surface, onto this surface knurling has to be done. Another common example which we can easily understand is, let us say we talk about a cricket bat. So in a cricket bat, wherever you hold the bat, there is a grip. So this is the basic drawing, and over here you can show the grips. So the multiple grips are being used by the batsman to make sure that you can hold a bat in a proper way. Similarly, you have the motorcycle handle where once again grips are being used. So the basic handle will be of this shape. Depending upon the grips, I can show the chain lines over there. So these are different types of lines which we need to understand. And having discussed these, let us see the examples. So here you have the extension line. This is a practical engineering drawing. This is your dimension line. Again, you can see a phantom line. This is the component in the idle situation. But this lever can move into this position. So the chain line is there, or the ditto line is there, phantom line, and this indicates that this particular component part of the machine can move into this position. So this indicates a ditto line application. Again, you can see a dotted line. Dotted line means that there is a hole for a screw. This is the visible line or the outline. This is your center of symmetry line. This is your center line. So this way, different lines, they have been shown into this application, and there are different line groups. So if you want to use highest thickness as 1.2, your thinner line can be up to 0.4 millimeter thickness. If you are going to use the line group of 0.5, your thick line will be of thickness 0.5, then your thin line will be of thickness 0.2 millimeter. If you are using line group 0.8, so your thickest line will be 0.8, while your thinnest line will be of 0.3. And if you are using 0.3 thickness, so your thickest line will be 0.3, while your thinnest line will be of thickness 0.1 millimeter. So these are different types of lines that we have discussed. Now in the last portion, we are going to see how we can go about drawing all these lines onto the drawing sheet, so that this text we write down in the Gothic lettering and these conventions we write down onto our drawing sheet to develop a better understanding of different types of lines and how do we write down the Gothic lettering onto the drawing sheet. So I'll just give you a brief description in the next portion. So here you go. Here we have the drawing sheet. So these are the margins and the title block which is shown. Now here the space is less. So you can check there is one title row and 10 rows for 10 types of lines are there. So I want to keep 20 mm height for every row. So usually when I draw it onto the drawing sheet, here you can see, I'll just show you, when I draw it onto the drawing sheet, 11 rows are to be drawn. But here, since the space is less, I will assume that only 5 first rows I will be drawing. So let us see how we can go about drawing all these conventional lines onto the drawing sheet. So please check. I have left 20 mm space from the top, drawn a line horizontal with the drafter, leave 20 mm from this side, leave 20 mm from this side. Then vertically, because 6 rows are to be drawn, so 120 mm vertical length I have drawn. But once we draw it onto the drawing sheet, for 11 rows 220 mm depth we have to draw. Here once again, because 6 rows I am going to draw, one is the title row and 5 are the different types of line. So only 120 mm depth I have drawn over here. Now 6 rows, you can see 20 mm each depth I have drawn. The first row is corresponding to the title row and 5 rows are there for 5 different types of the line. So here I have to write the serial number. Here I have to write the description of the line. Here I have to write down the convention. So please see, for serial number I am going to leave 40 mm distance from the left side. So 20 mm I have left over here. 40 mm is required for writing down the serial number in the Gothic lettering. Similarly, 100 mm is the length of the line which I have to draw. 25 mm from either side I am going to leave as a margin. So 150 mm is the width of the column which I am going to draw from this end. So this width of the column is 40 mm from this end, and this width of the column is 150 mm measured from this end. And 100 mm line I have to draw, so I leave 25 mm from either side. So these are two construction lines which I am going to draw. You can see construction lines will be lighter ones, whereas otherwise outlines will be darker ones using HB pencil. So the basic framework we have designed. Now you see, this is the title. Title has to be drawn on a bigger scale. That is, larger title has to be drawn. So the height was 20 mm. I have to write all my alphabets in the Gothic lettering 7:4, because the title I have to draw bigger one. So I'll be drawing it on a scale of 2:1, that is 14:8. If I have to draw 14 height and 8 width, so I have got the depth of this row as 20. So 3 mm from the bottom, 3 mm from the top. I will draw 2 construction lines. You see, 2 construction lines I have drawn, leaving 3 mm from the top and 3 mm from the bottom, so that this guideline is having a height of 14 mm and 8 mm width. I will write down on my own depending upon my experience. Then 14:8 is the ratio because this is my title row. So what similarly at the bottom I have to write down lots of information regarding types of line because multiple lines are there. 3 types of lines I have to write down. So I cannot write it 14:8. I will write down my characters or alphabets in the ratio of 7:4 over here. Just see 7:4. If I have to write down 7:4 ratio, depth was 20. So total row depth was 27 I have to require. So 6.5 I leave from the top, 6.5 I leave from the bottom. So 13 I leave and I get the ratio of 7:4. Now here I have to draw all my conventions in the middle of this 20 mm. So this distance left is now 10 mm. So I cannot write 7:4 because space is less. I will write down the thick line, thin line or a medium line in the ratio 5:4. So this is 7:4 doubled because this is a title. This is 7:4 Gothic and this is once again 5:4 Gothic because lesser space is available. Now let us write down serial number. I'll write down in the Gothic lettering serial number over here just like we did it onto the graph. So this we have already discussed in our previous lecture. Then the object, once again Gothic lettering I'll write down over here at the center and the convention I'll write down over here. I'll just show you how we have done it onto the drawing sheet as well in a while. Then serial number 1, outline or the object. This is a dark line. Thin or thick I will write down 5:4 because total depth is 10. So I leave 2.5 from the bottom, from the top and 2.5 from the bottom. So 5:4 I'll write down this thick. Then the second line, serial number 2, it's a hidden line. Once again 7:4. This is a medium line. So I'll write down medium again in 5:4. Third one is the center line or the locus line. So again this is small, big, small, big, small, big. And again I'll write down thin over here in 5:4. Then fourth one, construction, projection and section line. You see quite a lot of text is required. That is why we are writing it in 7:4, not in 14:8. Then this is a thin line. No need to overwrite something. Write down thin in 5:4. And finally the fifth one, dimension and extension lines, write in Gothic lettering. And then this is again a thin line. Put down thin. So length of every convention line is 100 millimeter. Now here I have to write down the title of my drawing sheet because this is second title. This one is the main title of the sheet. So I will write down types of lines in the ratio again 7:4 but multiply by 3. So 21:12. So the distance between these guidelines, the height is 21 mm. So this height is 21. So again Gothic lettering I'll write down this. Onto the drawing sheet the remainder 5 sheets also are to be written down. And then this is how we have completed the sheet. Or I have even prepared a video how do we draw this particular thing onto the drawing sheet. So how do we draw all these lines over there? So this is one description. Each row depth is 20 mm. So you can see 11 rows are there, 10 for each line, 1 for the title row. So this depth will be 220 mm. This is 40. This is 150 over here. And then this heading will be written in 14:8. These subheadings will be written in 7:4. These nature of the lines will be written in 5:4. And title of the sheet will be written down in 21:12. So this is how you can write down, you can carry out the practice of Gothic lettering as well as the different conventions regarding type of the lines onto the drawing sheet. So this is another one that we have shown over here. So this is all about different types of lines and their applications in the engineering drawing. So I hope you might have understood all the basic principles underlying the applications of different types of lines used in the engineering drawing. Thank you very much. Thanks a lot.